Good morning. I'll get started with chapter 6, which is developing a project plan. Now, we have done some of the chapters before, chapter 1, chapter 4, chapter 5. So now we'll get started with chapter 6. So all this while you have understood what an project is, what is an work breakdown structure, what are the techniques you use to estimate an project. Now in this chapter we'll try to understand how do you draw a project in a network diagram. So let's get started. So in this chapter, as I said before, we'll draw a project network. It's a flowchart that graphically depicts the sequence of interdependent activities. Okay, so again I repeat that. So a sequence of interdependent activities which are displayed in a graphical format. Okay, that's a network. Again, we'll take a closer look at that. And the other thing which is introduced in this slide is that of the critical path. The critical path is that path which take the longest time from start to finish. But I really haven't explained you what a path is. Path is a sequence of activities which are linked with one another from finish to start. So one activity finishes, the other starts. So there are sequence of activities which which get started from the day 0 and ends at the end of the project. So that's a path, and the critical path is one which has the longest duration. So once you draw a network, you will be able to understand first you will be able to understand what are the different paths available in that network. Then you'll be able to estimate which one out of those is the critical path. WBS, work packages to network. We have done this WBS before, work breakdown structure, where we break the project into smaller activities or packages. Again, the WBS takes place in different levels. In the level 0, we have the whole project. Then if you go to level 1, we break down the project maybe into 4 different packages. When you go to level 2, so each of those individual packages can be broken down into further sub packages, and this goes on. So over here we see like the end product is a circuit board which can be broken down using the WBS what I would say like guideline into packages. Over here the packages are design, production, test, systems, and software. Excuse me. So those are the major packages in which the WBS can be broken. In this slide we see what are the different activities which are part of this network. Again, the network is meant for building a circuit board. The activities are activity A. Let me grab a pen here. So we have an activity A, we have B, we have C, D, F, K, and the arrows shows the connection of one activity to the next activity. So over here, the first thing you should understand that you have a predecessor activity, like an A is the predecessor of activity B. So that means if activity A is not completed, activity B cannot be started. And activity B and activity C, they are parallel activities, which means they can be done simultaneously, or both can be executed at the same time. Now, some of the terminologies which are important for a project network are activities. Again, we have discussed this term before, an element of the project that requires some time. Okay, so that's an activity. Over here, A, B, C, D, they are all activities. Then we have merged activity, an activity that has two or more preceding activities on which it depends. Over here, D is a merged activity. You cannot start D unless and until you are done with activity A and activity B. So D is a merged activity. Then we have the concept of parallel or concurrent activity, which means activities which can be which are independent of one another or which can be executed concurrently. Over here, A and B are concurrent or parallel activities. Activity D and activity C, they are parallel activities. Event is a point in time when the activity is started or completed. So event does not take any time. So you have an activity so it has a end time, so that is an event, so it ended. Next concept is a burst activity, an activity that has more than one immediately following activity. So over here A is the burst activity because B, C and D depends on A. B, C and D cannot be started unless and until activity A is completed. Now in this diagram, these boxes, they are called nodes, and these arrows and we have arrows connecting these nodes. Over here the activities are shown in the nodes, so it is called AON, activity on node. We could have drawn it in a different way. Say this is a node, that is another node, and the activity connect the nodes. So we have node 1 and node 2. So node 1 and node 2 are basically events, and we have an activity joining the two nodes. So if I draw the diagram in that fashion, it would be called activity on arrow, AOA. Now these are the general rules which we follow while drawing a project network. Network typically flow from left to right. So if you have taken a note of the networks we have drawn so far, you will see they are starting from left and it moves right. We start with A, B, C, so A is written on the left, it moves on the right. An activity cannot begin until all preceding connected activities are completed. We have discussed that. So we have this preceding connected activities. Arrow indicate precedence, and flow can cross over each other. So there can be activities which are linked with, say, activity A and D are linked, where activity C and B are linked. So there can be different combinations of those. Each activity must have an unique identification or unique identify number that is greater than any of the predecessor activity. Okay. The looping is not allowed. It should not be a cycle. It should not come back to the same origin. Conditional statements are not allowed. Use common start and stop nodes. Okay, so as we progress further in this chapter, you will understand each of these points even better. Over here we see activity on node. Again, this is what we had done before. A is preceding by nothing, so A is the beginning, it doesn't have any predecessor. B is preceded by A, C is preceded by B. Okay, so they are in a series. Y and Z are preceded by X. So Y and Z can begin at the same time if you wish. So X is the burst activity, and we have seen this before. JK and L can all begin at the same time if you wish, but need not occur simultaneously. You can do or may not do them simultaneously, but you can. Okay, it can be done but not necessarily done. Okay, you can do J later on, that's fine, but only thing which is you have to make sure is all three of these activities are to be completed before you start M. So M is the merged activity. M is the merge activity. Z is preceded by X and Y. Okay, so you have to complete both X and Y before you start Z. Same as double A is preceded by X and Y. So you have to complete X and Y before you start any of these two activities, Z and double A. Now, this is the way you usually write a network information. So this is a hypothetical project, a coal business center, a county engineering design department, they are doing this. Okay, so these are the activities here on the left hand side. This is the description. This is the description here, and we over here the preceding activities, that's where we write the relation. Like A, it does not have any preceding activity, whereas F, it has got 3 preceding activities. So if you are given this information, you should be able to draw a network out of it. So based on the previous information, B has got A as its predecessor, similarly C and D. So from this network, what we understand is you have to complete A before you start B, C and D. And again, B, C and D are parallel activities. They can be done concurrently, but it is not necessary. You can finish B and then start C. There is no restriction on that. But what the restriction is, you have to complete A before you start both B, C and D. So these are parallel activities which can or cannot be started at the same time. So it is the discretion of the project manager. So now we keep on adding more activities, E, F, H, G, and this is based on the information which was provided in that table. The table gives us the Now in this slide we learned two very important concepts. One of the concept is that of forward pass, and another is backward pass. So what you should understand is we have drawn a network. Okay, and you should practice drawing this network. Otherwise you will not really gain that skill of drawing a project network. If we calculate the start time and the end time of each of the activities from start to finish, if we move from left to right, it's called a forward pass. And in forward pass we calculate the early start and the early finish. By early start I mean when an activity can be started the earliest, and early finish is when it can be ended the earliest. On the flip side of that, in the backward pass, we calculate the activity timing from right to left, and in this backward pass we calculate the late start, how late an activity can be started, and the late finish, how late an activity can be finished. So that is the two big difference between the forward pass and the backward pass. So again over here we take a look at some information about a project network. We have activities A to activity H. So we have the activities here, then we have the preceding activities where we get the relation, and we also get the timing of each of the activity. So based on this, once you are given this information, you should be able to draw a network diagram, and you should practice it. Practice it without seeing what is drawn over here. Draw it few times, you will understand the tricks of drawing a project network. Now, this is a typical method by which a project network is drawn. First, you should take a look at the legend here. What does it say? We have early start, we have early finish, the project duration, then we have the late start, the late finish, and the slack. This is the slack. Okay, and ID stands for which activity it is. So if you see over here, we have activity A, B, C, D, E, F, G, H, whatever, and they're connected. And this 5 over here in this bottom row in the middle, that's the project, that's the activity duration. So 5 is the duration of activity A, 15 is the duration of activity B, and it goes this way for all other activities. Now activity A, because it is the first activity, it doesn't have any predecessor. It starts from day 0. So it starts at day 0 and it has a duration of 5. So the early start of activity A is 5. Okay, so this 0 plus 5 will give you this 5. So 0 plus 5, sorry, this is a plus here, will give you a 5. This 5 will carry on here. So the earliest start of activity B is on the 5th day, or basically it's on the end of the 5th day, then when you can start activity B, and it has a duration of 15. So the earliest end time or earliest finish time of activity B is 5 plus 15, which will give you this 20. This 20 over here. Okay, now the interesting thing comes here. For the activity E, which is a merged activity where two different activities merges, activity B and C merges in activity E. Now activity B ends on the 20th day and activity C ends on 15th day. When can we start activity E? We can start activity E on the 20th day, not on the 15th day, because on the 15th day the activity B is not yet completed. Now this slide talks about the forward pass. We have already seen this. The early start plus duration, that will give you the early finish. I think I have explained that. Carry the early finish to the next activity where it becomes the early start. Again, we have seen this before. The next succeeding activity is a merged activity. In that case, the largest, so in that case it was 15 Now for the backward pass, we start with the end of the project date, and from there we move backwards. So for this activity age, it ends on 235 days. So over here we have the early finish, which is 235. So for this activity, for the end activity, the early finish and the late finish, they're both same. So we start from there, 235. If I subtract this 35 from 235, I get this 200. So that this 200 is the late finish of activity age. Now I have got activity E and activity H. So the late finish of activity E and activity H would be 200, same as the late finish of the predecessor activity. Okay, but the interesting part will come, I would say, it would come in activity C, okay, which is a burst activity. Activity C is a burst activity. We have two activities, E and F, moving out of it. So we have 185 and 20. So the late finish minus duration will give you the late start. The late start is carried over to the preceding activity, which becomes the late finish. For burst activity, it is the smallest late finish which becomes for the next succeeding activity is the burst activity. In that case, the smallest late finish of all the preceding activities is selected. So you had C over there, you had, say, I'm just giving an example, so EF, and the late finish of this is 20 and this is 35. Sorry, these are the late starts of activity E and activity F, 20 and 35. What we have to do for the late finish of C, we have to choose Now here is a concept of free slack, which means the difference between the early start and the early finish, or the late start and the late finish, is known as free slack. In layman's term, free slack means by what duration the activity can be delayed. So you have a early start of 5 and a late start of 7. That means that activity has got a slack of 2 days. So if we have an early start of 5 and late start of 7, that means that activity can be delayed by 2 days, and that's the free slack. Then the sensitivity, the likelihood, the original critical path will change. So you have an original critical path. If the project is delayed, if the activities are delayed, the likelihood that the critical path will be changing, that is the sensitivity. The other thing is like in the critical path, each of the activities, the critical path of the network has the least slack in common. Basically what we see in a critical path, none of the activities have got any slack. You cannot delay any of the activities. If you delay it by even 1 day, the project would be delayed. So that is a critical path. So we over here in this slide, we see another concept of free slack. So what is that free slack? We see over here this activity 2. So activity 2 is this one here. It has got a total slack of 16, okay, which is the difference between the early start 2 and the late start 18. So 18 minus 2 will give you that 16. But the problem is, if this activity is delayed, if it is delayed by that 16, instead of ending on the 6th day, it will end on the 22nd day. So the next activity will not have any freedom, or it will not have any slack. So all the slack would be eaten up by this particular activity. So the difference between the early finish and the early start of the preceding activity, that will give you the free slack. Okay, so free slack for this activity is 0. But if I take the example of activity 4 is here. So it has got a free slack. It has got a total slack of 16. That's fine, that's same as the previous one. But it has got also a free slack of 16. What is it? So it ends on the 14th day, that is the early finish. This is the early finish, but the early start is on 30th. So even if it finishes on the 14th day, the next activity doesn't start on the 14th day, that keeps on waiting. And again, this happens in merge activities. So this activity 6 has to keep on waiting. Okay, so this has got a freeze flag of 16. Now we'll take into some of the practical considerations. Network logic error, we'll look into it. The activity numbering, use of computer to develop network, calendar days, and multiple start and multiple projects. So let us see what each of these are. This is an example of a cyclic loop. It starts from A and it ends in A. So this is the example of cyclic loop, which is illogical and it is not allowed in project network. We can use MS Project, which we learn or which you are learning to do to develop a project network. Okay, and if you see over here, like these are the different activities. Those boxes are the activities which are connected by arrows to show the relationship. Okay, and it has got the start and the finish. We've got the start and the finish. We have the ID and the project duration. You can also represent a project in a Gantt chart format. We are using that MS Project, so that MS Project allows a Gantt chart format as well, where each of the activities will be shown by a bar and arrows would be drawn in that network to show the relationship. Now, laddering is a concept which is used in many project activities. Activities are broken into segments. So there is an activity A and activity B. Activity A and activity B. So it's not always necessary that activity A has to be totally completed before you start B. So maybe part of it is completed before you start activity B. So that is called laddering. So if you see a ladder over here, so maybe after 2 steps you can start activity B. So that is the concept of laddering. The lag is from you have activity A. If I draw a box here, activity A and activity B, and I can always give some lag, like it may not be 0, like right after you end activity A you may not start activity B. There can be a lag of 5 days. So that's lag, and that might be required in some project, and the relation can So this is an example of laddering. We have this activity where the trenches are being made, but when 1/3 of the trench is done, we can start laying pipes and think about it in a practical viewpoint. Like you have a trench, we have a long trench, we have to first dig the trench and then we have to lay pipe. But you need not dig the whole trench for laying those pipes. You can maybe done with part of it and then you can lay the pipes. Okay, and you keep on digging. So after the second part is done, you lay pipes. So this is an example of laddering. So over here we see a relationship of that lag. So A, we have activity X and Y, and A can end at some point of time. There has to be a lag of 19 days. Say after the substructure is done, substructure of a building is done, maybe you have to give some time for the concrete to settle down or to solidify before you can start the superstructure. So you have to give a lag, and that lag can be, the relationship can be from start to start, or it can be from start to finish, or from finish to start. So there can be different type of relations for this kind of lag where we introduce it. So over here we see a lag of 3 days between start to start. So after you start digging the trenches, you have to give a lag of 3 days before you start laying down the pipes. So the basic concept is, maybe you will be doing part of the trench, the digging part, for 3 days, and then you'll start laying the pipes. And after you're done with the pipes for 3 days, maybe you can start refilling those trenches. Okay, so this is the basic concept. Over here we see the traditional sequential approach, where we see the activities are linked with one another in series. So activity like product planning and system engineering and system design, each one of them can be started after the preceding activity ends. But that need not be so. We can do concurrent engineering. What is that? The product planning and the system engineering, there can be some overlap. Okay, after you're done with part of the product planning, you can call your systems engineer, who can start along with the planning people to think about how the system engineering is to be done. Okay, so that is the basic concept of concurrent engineering. Again, over here we see the different type of lag relations which can be established. It can be from end to end, it can be from start to end, or it can be end to start, or whatever. So these are the different ways you can introduce lag, and if each of them will have some justification why at all you introduce that lag. One of that, as I said, like it can be you pouring the concrete and starting the superstructure, you have to give a lag. So we had done this network, we have seen this network before, and in that network it's possible to introduce a lag. So for that activity A and B, for start to start, there is a lag of 3 days. So that's the relation. It need not be like end to start relation. It can be from start to start relation. Hammock activities, an activity that spans over a sequence of a project, or over a segment of a project. So that part is, it's a hammock. So those swings together as if. The duration of the hammock activity is determined after the network plan is drawn. The hammock activities are used to aggregate sections of the project to facilitate getting the right amount of details for specific section of a project. So we can give some special attention to those activities which are in that hammock. So over here, activity B, D, and F is part of that hammock. So we designate that by that activity G, which can be broken up into activity B, D, and F. So all these three activities together make that activity G. So this is the example of hammocking. These are some of the key terms which we have seen: activities, AOA, AON, burst activity, concurrent engineering, critical path, early and late start, Gantt chart, lag relation, merge activities, network sensitivity, parallel activities, slack, float. Again, float can be total float and free float. So you should be familiar with each of these terms. Activity on arrow. So if you remember, I had drawn something similar in the very beginning of my presentation. We have two nodes, node 78 and node 80, and connecting them is an arrow which represents an activity: install software. Again, these are conventions. You can adapt activity on arrow or activity on network based on whichever you feel more convenient. Okay, but for this presentation, for most networks, we have done activity on node. So node was an activity. Here we see the activity is on the network or on the arrow. So it's called AOA, activity on arrow. So this is the way an activity on arrow is drawn. So 1011 is an activity, 1112 is an activity. Similarly over here 512, 520, 1020, 1520, these are all activities. And again we can have the same type of relation what we have seen in AON, activity on node. The same concepts can be used in activity on arrow. So our chapter ends here. Again, this is a very important chapter where you learn how to represent a project in a network diagram. Again, you need considerable practice before you can start drawing your own project network. Thank you.